Grab your exercise books out. We're going to write some notes for C. And then D is probably the one where I want to spend some time to learn. And that's your holiday there. Okay, 7A, B, C, D. Come back next term. You're going to know your transformations. Let's go, girls. Exercise books open. Let's go. Here we go. Let's combine the things you've learned so far. You've learned translations, dilations, reflections. So the only hard part was dilations, where you have to make sure, remember, from X affects your Y. From Y affects your X. Reflection in X is the mirror here, so that affects your Y. And reflection in Y affects your X. Yeah? Now we're going to put all that together. That's what 7C is about. C is to put all transformations together and then find the equation. Yeah? Whereas previously you just found translation. Previously you just found dilation. Previously you just found reflection. Now in C you put them all together, and then in D you work backwards. And working backwards could be hard if you haven't done 7A and 7B, you haven't practiced that skill yet. Okay, visually it might seem hard, but in terms of skill-wise, you're doing the same thing. So, let's try this one. It says find the equation of the image. So really it's just saying find the new equation. If you have y equals root of x, so you got y equals root of x. No worries. And you want to do the following transformation. So let's do A together. Let's remind ourselves again. When you're doing your transformation, what does dilation of factor 2 from the x-axis will change? Dilation of factor 2 from the x-axis. What does that mean? Let's go with maths. Dilation. Good. Means from x-axis, from, so this is x-axis from, so you're moving away from, and that's affecting the y values. So when you say dilation means stretch, it's a times. So you're timesing. Factor 2 means 2 times the y values. So what you should have already is you should say 2y. That's what you're doing. So every old y coordinate, you're timesing it by 2 to get to the new. Then he says, followed by a reflection in the x-axis. Reflection in the x-axis. What am I affecting now? Let's go with Charlotte. What values am I affecting? If I said reflection in the x-axis, what values am I affecting? X or y? Y. Okay, so think of the mirror on the x-axis. If it was over here and the mirror would drop it down, so that has to go vertically. So that affects your y values. So if it affects your y values, how do you have a reflection again? What do you do with the transformation to get a reflection? So if it's not times 2, it's not add 2, it is? It's a negative. Okay, so in this case, it's a negative on the y, and the x stays as itself. Okay, so what you actually have now is times the y values by a negative 2, and that will give you dilation of factor 2 from the x-axis and a reflection in the x-axis. Okay? Now, your job is to rewrite the old equation, which is y equals root of x, and you want to rewrite that to have the new transformation. That means you need the new x and the new y. How do we do this again? How do I start off? I need to find new x, new y. What's the first step? Let's go with Yasmin. Not sure. Akita. What's my new x and what's my new y equal to? Oh, A. I'm doing A. So I got the transformations here. I just want to know what's my new x and what's my new y equal to?
Y is y dash divided by 2.
Yes, you are right. I just want to know the first step. Okay, all right. I will do this instead. So for those who are confused what I'm trying to say, this is your original x and y coordinates. This is what you're doing to the original x and y coordinates. What are you doing to that? This is the new x and y. So how do you get the new? Times the original y by negative 2. That's how you get the new. Yeah, because that's what I just told you. I said y, to get to the new, what are we going to do? Times the old by negative 2. So if you were to write, how do you find the new x and the new y? Well, to get the new x, apparently I haven't done anything to the old x. So old x is new y, new x. old y times my negative 2 will give me new y. Now you can solve for it the way that Akita was mentioning. We know that if we solve for the original y and original x, divide both sides by 2, yes. This will give you original y, this will give you original x. So from here, now you can replace the original x and y. See, that's the goal. So if you can't establish that goal yet, then 7D will be very difficult, because you have to understand what you're trying to find. In this case here, see, that's my original x and original y. I'm original. Then to get to the new, it says, we figured out the reading here tells us times by negative 2. There's over here. So this is new. This is old. This is new. This is old. Yeah? Old, new. Old, new. Nothing hard about it. Yeah? That's my new. So the new is apparently the same as the old. So that's why I wrote new x is the same as old x. New y is equivalent to negative 2 times y. That's it. Right? But my equation, which is what I started off with, is an old y and an old x. So I want the new equation. How do you get a new equation? You have to have new x and new y's in there. So that's why I rearranged it. Old x now equals to x dash. Old y, so I got y by itself by dividing negative 2 on both sides. And old y equals to negative y dash on 2. So I can replace these two now. I can say old y equals to negative y. I'll color code it for you as well. I just went, this goes here now, and this goes here. That's all I did. Nothing hard. That's from 7B, 7A. You've been doing the same thing over and over. Hasn't changed. Yeah? So you put that in. Now we don't write our equation, we don't finish there. That is the new equation. But we always write it where it's just y by itself. So I got to get rid of the negative and the 2. Now fractions, I know we didn't like it. What did I say? If you don't like fractions, what do you do? What do you do with the fractions? Multiply. If you don't like fractions, God, it says divide. Read it. It says y dash divide 2, then the opposite of dividing is times. So times 2 on both sides. See, if you just divide 2 and then times 2, you inverse. It's like saying add 2, minus 2. 0. Times 2, divide 2. Divide 2, times 2. Yeah, it's just like inverses. Year 7 mathematics where we're inversing the problem. So if you do this times by negative 2 on both sides, those will cancel out, and you end up with y dash, because if I times this side by negative 2, and I times this side by negative 2, that's now negative 2, negative 2's will cancel out. Okay? That's why I get y dash equals this. This is my new equation. So if you type this in your calculator without the dashes are just there so that helps you to know which one's the new, which one's the original. Okay? This is the new equation. So that's what the first part was asking. They just said, I want you to find the new equation so that I have this transformation. We read the transformation, we rearranged it, replaced the old, we got the new. Okay? Yes?
Should we remove the dash?
Yeah. In your final answer, if you're doing it in your exam, I'm just doing the dashes so you get it, but in your exam, you should just write minus 2 root x. You don't put dashes, I just said. You don't put dash. You put dash is fine, but your final answer has to not have dash.
Yeah, no. How about if I forgot to do it?
Well, then that's your problem, isn't it? Yeah. It's like saying, if you had the answers 2 or 4, and you're like, I forgot to halve it.
That's a problem.
That's a problem. That's you. Yeah? Change it. All right, here we go. Next one. We're going to read the transformation dilation of factor 2 from the x-axis. How does that change things? If I got x and y, I want to find what this means. What's dilation of factor 2 from the x-axis mean? Can I please have, let's go with Trent. What's dilation?
It's a factor of 2 on the y, so 2 alpha on y.
Good, 2 times the y. Good. Then it says translation of 2 units in the positive direction of the x-axis. What does that mean, Olympia? We have translation of 2 units in the positive direction of the x-axis. What does that really mean? Right 2. Okay, if I'm moving right, which one am I affecting, x or y? What am I affecting? X or y? If I'm moving to the right by 2. X. Okay, so you'd write x plus 2. That was simple. Yeah? Every time you add, you're moving to the right. Yeah? Whereas this one says 3 units in the negative direction of the y-axis. What does that mean now? What am I doing? Yeah. I am going to say moving down 3, so therefore I'm minusing the y values by 3. So I write it down. I'm like, okay, there we go. That's the formula. That's what I'm going to do to the original to get the new. Yeah, so the old plus 2 for the x, I'll get the new x. The old y times by 2 and then minus 3, I'll get the new y. So rewrite the equation. Yes?
So the direction of 2 from the x-axis. Direction of 2 from the x-axis. So it means like go off by 2.
No, dilation means stretch. Translation means up.
Yeah, no.
Down. No, you don't.
I mean like 2 in the y-axis.
2 times the y-axis, yes. You're right, yeah. 2 times the y. That's why I got a 2y there. See?
So it means 2 times, right?
2 times, yep. Dilation is always times. Yep. Now, rewriting things. This is your new x. I've got the equation. New y, I've got the equation. Your job is to rearrange it. So it's just linear algebra, back to year 7 maths. Rearrange it to find old x, rearrange it to find old y, sum it back into your original equation. Now, I've color-coded it. See x here by minus 2 on both sides. New x minus 2 will give the old. The old y, if I add 3 on both sides and then divide both sides by 2, I get that. Now I'll put it, sub the y back in, that's my green. Sub x, that's my red. Your job is to rewrite this equation where y is by itself. So let's think about it. If you have a fraction, what do you do again?
Times.
Times. It's not hard. Every time you get a fraction, just times the denominator. Times every single term by a factor of 2. So if I said times this by 2, 2's will cancel out and times that by 2. That gives you y dash plus 3, and that's easy. To get rid of a plus 3, minus 3 both sides. So this is my new equation. Okay, that's 7c. That's all you have to do for 7c. So that's what I'm saying. 7a, 7b, 7c are exactly the same techniques throughout. Was that easy? Cool? Now 7d. I really need you to sort of focus on the goal of 7d, then you get it right. Otherwise you'll find it tricky. It's not tricky, it's just more about the goal. Okay? So, I'm just going to skip through this and we're going to go back to this one. This is 7d. So now it's the reverse. The reverse is because they don't tell you the transformation anymore. See, 7c before, they told you dilation from the x-axis, reflection the x-axis, translation, but now they don't. Now what they do is they give you the old equation. They give you that this graph now becomes the new equation, which is here. Your job is to find what the transformation is. So what does that mean? That means you need to know what x dash is. That means you need to know what y dash is. Because remember when we did it in the other slide just then, x dash tells you, let's say it was x plus 1, x dash tells you what you're going to do to the original. So if I have x dash, I can say, oh, add 1 to the x means it moves to the right by 1. Okay? And that tells me the transformation. So your job now is to work backwards and find x dash. Okay? Now this is where it gets tricky. Here we go. I want you to copy this example down. You have these two equations. Original, new. I'll say it again. Original, new. So what will help you is if you put the dashes there so that it reminds you on these x and y's, put a dash so you remember this is your old and that's your new. Okay, so this is your old, that's your new. Now your job is to rearrange the second equation or the first so that they both look similar. Now what's different about them is this first one only has x squared. What's wrong with the second one over here? I got a plus 3 and I got a times 2. The first one didn't have that. The first one didn't have the 2 and the first one didn't have a 3. So these are new. Okay? I still have something squared though. The x minus 2, that's something being squared, which is the same thing as the first one. So when I'm replacing it, you can see that what am I affecting my x values? This x here is being replaced by that. So now you know, okay, so that's original x. To get to the new x, that's what I substituted. X dash minus 2 was replacing x. And that's how you know that's one equation there. But what's the 2 and the 3? You have to move over this side so that you can equate these two. Okay, so this is what I'm going to do. I'm going to say, all right, now that I know if I can move these two away so I can do the comparison, so I'm going to rearrange it. See, what I'm going to do here is I'm going to say get rid of 3, minus 3 on both sides. 3's cancel out. You get y dash minus 3 equals to 2 times x dash minus 2 squared. Now that's almost similar to the very first one. This one was just something squared. Now I do have something squared, but the problem is that 2. So I've got to get rid of that. So if that's times 2, how do I get rid of times 2? I would divide 2. So here we go. I'm going to divide 2 on both sides. And this is nice because now it gives me this equation. See what I've done? Now this is nice. Why is this nice? Because that was something squared. My second equation now is something squared. What's on the left-hand side here? That y is apparently replaced by this. So now you can equate that. You can say, okay, so that means old y is equivalent to new y minus 3 divided by 2. You can say this old x is being replaced by x dash minus 2. That's what you can see. So that's what you're replacing. You're saying something squared. What am I something squared here? That's my something. X dash minus 2 is being replaced with the x here. So that's why I can say x equals to x dash minus 2. Over here, what am I replacing with the y? I'm replacing it with the green. That's why this is equivalent to y. But what was our goal again? What was our goal from the very beginning? What were we trying to do? What were we trying to find? New x, to find new x, new y. So your goal is to find y dash, x dash. Right now, it's not the case. So if I want to find x dash, I've got to remove the minus 2. So here we go. From here, x dash has to equal to. Now that's key. So now you know parts of the transformation. To get to the new, you have to add 2 to the old. So what does that mean? If you add 2 to the x values, what are you doing? Right 2. So it's called translation of 2 units to the right. Yeah. That's the first sequence, because they're asking you to find the sequence. You found out the first one. You just found out to move to the right by 2. This one, you have to rearrange that to get y dash. You want to know y dash. That's why I'm saying 7D is tricky, only because of the goal. See, previously you were trying to find old y, old x. Okay, you're doing the other way. You're trying to find old, new y, new x. Okay? So here we go. I'm going to rearrange all that. I'm going to write it out here so it's a bit cleaner. Your goal is to find x dash, y dash. So here we go. I rearrange them. This is my old y equals that. Times 2 on both sides. Get rid of the fraction. Y dash minus 3. So if I add 3 on both sides now, what that tells me is to get the new y times the old y by 2 and 3. Now you can read the transformations here. If you have 2 times y, what are you doing? Is it dilation or translation or reflection? Dilation. I'll factor 2 because it's number 2. From which axis? From x. Okay, because you're timesing the y values. Okay, so timesing the y values. This tells me dilation of factor 2 from the x-axis. But if then you have plus 3 to the y values, what is that doing now? What are you doing when you put a plus 3 to the y values? Yeah, up by 3. So translation. You've got translation up by 3. If you do the x one, so you do the x, find out the x dash, you can see that moves to the right by 2. So your total sequence is right by 2, dilation of factor 2 from the x-axis, and up by 3. And that's what you have to say. You have to translate that. Now, there is a traditional way of writing things in your exam for next year. You can't write it in any order you want. The order that we go with is BUDMAS. Now, BUDMAS is brackets first, multiplication, division, addition, subtraction, yeah? Translations are your addition, subtractions. You always write dilation first. So the shortcut to that is Dr. T. Okay, dilation, reflection, and then translation. So you always write in that order for a sequence. So Dr. T. Okay, so dilation first, and translation doesn't matter which one comes first. Translation comes next. Yeah? So I did dilation of factor 2 from the x-axis. That's the 2 times the y. I did translation 3 units up, which is that one. And then I did translation 2 units to the right, which is that one. That's 7D. Okay, so 7D is tricky only because of the goal. You have to find out how to find x dash, y dash. And the reason why it gets difficult is it this example? Oh yeah, it is that example. The reason why this example is tricky is because now you're moving from this is the old equation to the new. And the funny thing is this, if I just forward it to you and you can see, I rearranged it and I can compare now. I can say y over 3 equals y. This is the old, that's the new. So now if that's the new, that's y dash. And that's the new x. The funny thing is you don't have to do anything else. You see, if that's the new equation, that's the new equation, you already got y dash. If that's the new x, you already got x dash. You don't need to move anything now. The transformation's there. You don't have to do anything. You can read it and say that's to the left 1 and dilation of the factor third. Okay? The third from the x-axis. That's why that kind of problem is tricky, because you don't have to do anything. With 7A, 7B, 7C, you've been doing things, you've been moving it around. So that's why I'm saying you've got to know the goal. What is your goal? 7D, the goal is to find y dash, x dash. If you keep that in mind, you're not going to try to rearrange this, because my year 12s will rearrange it. Okay, they get good at doing this. So my year 12s, when they first learn transformation, they're learning everything I'm teaching you now, but in a shorter time frame. They do it in one session. Okay? So they only have the one session, and they'll get really good at this. And they can find x dash, y dash, they can find old x, find old y, they can find new equation, they can read it, they can graph it. Their problem is not understanding the goal. Okay, so the goal is, are you trying to find the sequence, or are you trying to find the equation? So before we were finding equation, now we're finding sequence. So when you're finding sequence, it's x dash, y dash. And then in exams, they will give you this kind of problem. They will give you the reverse. They'll give you the equation, and they say that's the new. And the nice thing about this is this is going to be easier, because that's y dash, x dash. You're all done. So all I have to do is just rearrange that plus 6. I just move that across. I can read the transformation straight away. See, if I just look at this equation here, that's the old y equals 3 over x minus 1 squared plus 6. If I rearrange it, it's y minus 6 on 3 equals 1 on x minus 1 squared. Okay, so all I did, minus 6 on both sides, divide both sides by 3. This is the old. This is the new. So if I compare it, if I write it in blue now, if I write in blue, see this is my new, y dash equals to 1 over x dash squared. You don't have to do anything now. Y dash equals that, that's your transformation. X dash equals this, that's your transformation. There's no need to do anything else. You can just simply say, here, y dash is apparently equating these two. So y dash is y minus 6 over 3, whereas x dash is x minus 1. You don't have to do anything else. Okay, because we've already got x dash. That's the beauty about it. You don't have to do anything, and the year 12s feel like they have to do something. You don't. So at this point here, you can just say x dash is just left by 1. Y dash, probably split up the fraction so you can read it. Okay, split up the fraction so you can read it. But otherwise, that's why 7D is just tricky there. Okay, so if I split up that fraction, in case you're having troubles with that, that's y on 3 minus 6 on 3, which is 2. So that means down 2, dilation of factor a third from the x. Okay, so when it's y divided by a third, it's the same thing as saying a third times y. So that means the dilation of factor a third from the x-axis. Okay, so that's 7D, but like I said, I want you to practice 7C first. 7D is for your holiday homework. Okay? That's transformations. Okay, when you come back, we'll be moving on to matrices and whatnot, but I want to revise that before you move on. Yeah, so holiday homework, 7A, B, C, D. Make sure you have that under your belt. I'll upload the videos afterwards. Okay? I've got the videos on my computer, I just haven't uploaded it yet. Yeah. You said sir before. You said something.